Okay, so unfortunately I should have recorded it. Okay, so I show you the part here. So this is work 2 so not this, not this. Okay, where is it now? So I must select the one with yeah, this is the one. Let's start recording. So let me recap. Okay, what is the question about, right? So question about is this one. You have to do completing a square, right? Completing a square is x squared by kx equal x plus k over 2 square minus k over 2 square. So you complete the square for x squared by 2x plus 17. Just concentrate on the first two terms first. Okay, first two terms first, and then add the 17 back, and then you get x plus 1 squared plus 4 squared. So bear in mind that 1 over x squared by a squared, when you integrate, is not long. Okay, so this is the wrong formula. If you look at example in the book, okay, you can see that they didn't use this formula. They use tangent inverse formula. This is a 1. Okay, this is a 1 tangent inverse formula. So don't always think that 1 over something is a log. Okay, so after you finish this already, then you are to so 2x plus 1 over x squared by 2x plus 17. So this is the hard part now because you do two things. One of them is substitution. So first complete the square first, then you do a trick. This trick is very special. You change the x to x plus 1. Okay, then you must balance it. Okay, 2 times x plus 1 and 2x plus 2. But you don't want to get 2x plus 2, right? You want 2x plus 1. So you must think how to arrange them. So you get 2x plus 1. So one way to do is minus 1. Okay, so that get back the original 2x plus 1. So these two terms are equal. So this term, of course, is equal to this one. Okay, then you split. So then you split here. Split the two terms. The second term straight away use the earlier part. Okay, the earlier part here. Then the first term you have to do substitution. The here you go x plus 1 square plus 4 square. Then everything come out nicely. You can cancel. Okay, you cancel the 2x plus 1, 2 times x plus 1 can cancel away to become EU. Okay, so this is the first problem I explained to you. Okay, although I didn't manage to record the video. Never mind. Let's try other question. You see other question. So let's try another one. Okay, some of the question I think you asked yesterday, right? I'm not sure which class asked this. I think you might have asked already. Okay, let me do a simple one for you. Let me do a 5A for you. Okay. 5B also quite easy. I'm not sure where I did for you already. Let me do 5A first. How to do 5A, right? So, question 5A. Simple one first. Okay, so I'm going to start the page here. So 1819 S1. Question 5A. This one they tell you have to do by part. Okay, so by part you must follow the rule, right? Rules tell you that LIATE. LIATE. So in this question, there are A. A is 2x minus 1. There are E is e power x here. So you know A comes before E. So you must let U equal to 2x minus 1. Then dv is equal to ex dx. Then for u you do differentiate. So differentiate first. For v you integrate. So differentiate 2x, you get 2. Differentiate 2, you get 0. Okay, how about integrate ex? Ex is a very stubborn function. You integrate ex, you get back ex again. Then one more time, integrate ex, you get ex again. Okay, so then you can find afterward the standard procedure. You draw downward arrow, plus sign, okay, downward arrow, minus sign. Okay, I missed this one, okay? Downward arrow. So this is the plus sign first, plus sign. So this is minus sign. So if you be careful of this, minus sign, and then the plus sign. So your u is starting from 2x minus 1. So the 2 column, okay, 2 column there. So no need a bit troublesome like this one. Okay, your u is ex here. U is 2x minus 1. So now you together with the sign, the 2x minus plus 1, then ex together plus sign. So this is actually equal to 2x minus 1 times e power x first. Then the next term, okay, next term, 2 here, together minus sign, ex, multiply together, you get minus 2, then times ex, right? Now, that term do more with it, 0 times everything is 0, so that's what plus C come out. So altogether is how much? Okay, you can see that this is actually 2x ex minus ex here minus 2ex here plus c. So basically it's actually 2x minus 3 times of ex here, okay, plus c, because these two can be combined together. Okay, combined together these 3 terms. Okay, this term and this term combined together, you get minus 3. Okay, so you get minus 3 ex. So this will give you minus 3 ex. So we can combine them together. Okay, maybe I write another step here. So that this is 2x ex here, 2x ex here, minus 3 ex, okay, plus c. And then you combine them with 2x minus 3. Okay, so this is actually using integration by part, where this time your integration by part stop. Okay, because we have 0, very easy to use, right? We have 0 here, so very easy. The best scenario. Okay? 0 times everything is 0. This is the best case. Okay, 5A. Now 5B will be slightly harder. Okay, 5B. So this is 5A first. So I can ask to you how to do 5A. 5B will be slightly harder. First 5A, we already had to do integration. Okay, so I expect usually there are some simple questions for you to start, and then gradually they have a harder one. I hope this is the case. They won't give you a immediately a very hard question. Just start with a simple question, warm up first. Okay. So I want to look at 5B now. 5B. So I go back to copy 5B for you. Okay. 5B is this question. This other question now. Okay, some of you might have done already. So now you want to get more questions, there's revision tutorial inside there for MST. So you have more questions to try. But they're usually harder. I mean, the test question usually are easier. MST question usually are comparatively easier than. Yeah. So this one again by part again. Okay, by part again. So this is actually 4B. Okay, let me check. Okay, 5B, sorry. So this is 5B here. So again by part again. So by part, the first rule you always remember is using LIATE. LIATE. First thing, right? L for log function, I for inverse trigo, A for algebraic, T for trigo, E for exponential. So you look at what are the functions you have. You have this log x straight away under L. You have x cubed under algebraic here. So we follow that. Okay, U always for L. For the sequence, whatever the in front is a U here. So let U equal to log x here. So U is equal to log x here, and dv equal to x cubed dx here. Okay, for U, you have to differentiate there. Differentiate. Okay. For V, you have to integrate. So let me drag this a bit here. So get a space on right. Okay. So the for dv, you integrate here. So differentiate log x, get 1 over x, everybody know by now. Okay, differentiate log x, get 1 over x, standard differentiation formula. Okay, integrate x cubed. Okay, use the power law now. Integrate x cubed with x power 4 over 4. Now, this situation is different from earlier one because in earlier one, you differentiate until you get 0. This one will never get 0. So we stop here. We get a plus sign. Then horizontal arrow, minus sign, right? When you stop, you cannot continue anymore. So you draw horizontal arrow. The meaning of horizontal arrow means that this is actually, it means you have to integrate now. Integrate the product. Okay, integrate product, okay? Integrate product, then you get horizontal arrow. So how to find the answer now? Okay, let's start now. Is equal to. Okay, so you have, let's see, I have this one to get a plus sign to get an x4 over 4, right? These three terms multiplied together. Together with minus sign in arrow. So what you get, the first term is actually x power 4 over 4 ln x. This is first term. Then the second term is what now? Together with minus sign now. Second term, you must have this one together with minus sign, multiply together, then integrate. Okay, all these multiply together, minus sign, integrate out. So what you get now is this term is minus sign 1 over 4 x here times x4 over 4, then integrate. Okay, so how do we integrate this one? We cannot integrate this one term by term. Okay, no such integration rule, no product rule for integration. So what you can do is you cannot integrate term by term, so cannot integrate term by term. What you did is simplify first. Take out 1 over 4, then 1 over x times x power 4, right? So 1 over x times x power 4 is actually x power 3. Okay, you cancel. Okay, cancellation. First, right? So 1 over x times x power 4, you get x over 3. Take out 1/4. So this is what you do. Okay, you cannot integrate one by one. Okay, you cannot say integrate 1 over x, get 1 on x, integrate x power 4 over 4, get x power 5 over 5 times 3. So cannot do this. Okay, just simplify this first. Okay, there's no product rule for integration. So now this is actually integrate directly now. So this x power 4 ln x is minus 1/4. Now integrate x power 3, x power 4 over 4 again, power rule as a constant. So in the end, get x power 4 over 4 ln x minus 1 over 16 x power 4 plus a constant. Okay, so this is how the solution is acceptable. Okay, so this is how you do 5b, where when you do integration by part, you see that when you don't get 0 now, so you can actually draw a horizontal arrow. Okay, so sometimes you need to draw horizontal arrow because it will stop. Okay, so this is 5b. Okay, any message from me? Just match it there. Okay, fine. Okay, nothing in the message there. Okay, I think Dina is not there. Okay, Dina is not there. Okay, looks like Dina is not there. So this is question 5b. Let me look at another question. Okay, let's look at the question. Okay, there are many questions inside the MST. So you run out of question. If you run out of question, you can look at MST question, right? So 6, I can do a read. I mean, so there are periodic number, no Fourier series, so you need to do. So I think 5C I did for you already. So not much you can do unless you want to do. Okay, chain rule. Okay, I do a question on chain rule first. So 2.1b. Okay, must know how to do a simple question. So I'm going to do 1b chain rule. page here. Okay, so 1b. Okay, 1819 S1, question 1b. So they give you the z as a function of x and y. Well, x equal cosine t, y equals e to t. Find out the dt now. So you have to know degree of differentiation. So what is the formula for chain rule? Okay, z depends on x and y. So the first thing you write is chain rule now. Okay, dz dt is partial differentiation on z with respect to x first, then multiply by dx dt. Then partial differentiation of z with respect to y first, then multiply by dy dt. This is called chain rule. Very important. Most likely, it's other than differentiation, they will ask you chain rule. Okay. Other than normal differentiation, I think they will ask you the chain rule. Okay. The chain rule formula inside your notes, okay, is in somewhere. There could be chain rule or percentage chain rule. Okay. So there are many issues you can do the chain rule. So this is actually in page 15. Similar there, different version, but this is on page 15 in the notes there. Okay, differentiation of z, the of z is z f y now. Okay, so this is the situation. So this is what happened is your f x y lah. Okay. Okay, what is dz dx here? Let's try. So z is equal to x squared plus 3xy squared. So partial differentiation of z by respect to x here, you treat y constant. So differentiate x squared get 2x. You treat y constant now, so y squared constant, 2y squared constant, differentiate x, you get x 1 here. Okay. So there's 3y squared, so there's 3 here, sorry. Do it right, messy here. So the y is 3 here. Okay, you treat y square, 3y square constant, differentiate with respect to x, you get 1. Okay, dz dx here. And how about dz dy? Partial differentiation with respect to y. That means you treat x constant, okay, differentiate by respect to y. So treat x constant get 0 here. Okay, differentiate y square, you get 2y. Okay, differentiate by respect to y, get 2y. And then treat y x constant. So treat x constant now, divide y square get 2y. So this is actually 6xy. Okay, so then what to do other thing? You know where is dx dt now? Okay, so what else? So you know x is cosine t. So dx dt, differentiate cosine, you get minus sine. Okay, x is cosine t, so differentiate cosine, you get minus sine there. So this is negative sine t. Okay, y is e power 2t. So how differentiate e power 2t? Differentiate t and dy dt now is e power 2t. Then differentiate 2t again. This is called chain rule. So you get 2e2t. Hello? Yeah. Yeah, weapon. Oh. Oh. Okay, can I call you back later on? Yeah. Okay, can. Yeah. Okay. Okay. Thank you. Okay. Okay. Now, sorry about the interruption. So what I'm going to do is I want to find what is dz dt now at t equal to 0. So when t equal to 0, what happens? When t equal to 0, what is x now? X is cosine 0, right? Cosine 0 is 1. Okay, when t equal to 0, x is cosine 0, so x equal to 1. When t equal to 0, what is y now? Y equal to e power 2t. Okay, 2 times 0, so e power 0 is again 1. So basically, everything x equal 1, okay, dx dt. Then how about the dx dt now? When t equals 0, so dx dt is equal to minus sine t, right? So dx dt, you get this. Okay, let me pull up a little bit here. Okay, dx dt will be equal to minus sine t here. Minus sine t will be 0. T equals 0 now. So sine 0, cos 0. And then dy dt is again 2 times e power 2 times 0 is actually 2. So I can pull down the this. Okay, so let's write down this. Dz dt is equal to, okay, partial differential with respect to x plus 2x plus 3y squared. Then dx dt is minus sin t plus dz dy is actually 6xy. And then dy dt is actually 2t, right? So put t equal to 0. So this is equal to x equal to 1. So this 2 equal to 0. So anything basically is 0 now. So sine 0 equal to 0. So this thing not counted anymore. Anything times 0 is 0. Okay, next one is t equal to 1. So t equals 0 here. So 6 times 1, because x equal to 1 now. Y also 1. Okay, 6 times 1. 6 times x times y times e power 2 times e power 0, which is 1. So altogether, you find that this is actually equal to 12. So this is equal to 12. Okay, so this is how you do question 1b using the chain rule. So this is 1b using chain rule. Let's see any message or any request. No, Dina is still not here. Okay, let's see any more question or any particular questions. I'll just pick some question to you. Okay, partial differentiation. Okay, I just do a simple one. Do 1A part 1 first. Okay, a simple one. Okay, now. Okay, so next page here. Very simple one. Okay, how to differentiate this one? Okay, fine. So understand notation this one. This notation, what does it mean? This notation means partial differentiation of f with respect to x. Okay, basically you are differentiating, keeping x y constant now, ln x squared minus y. So you must know, okay, keep y constant, what do you get? Differentiate ln something, you get 1 over something, right? So this is 1 over x squared minus y. But then you cannot stop here. You must differentiate the x squared minus y. This is called the usual differentiation chain rule. So now differentiate with respect to x, keep y constant. So this is actually x squared minus y, then 2x. Y is constant now, of course it's 0. Y constant 0. So you get 2x over x squared minus y. It is how to do partial differentiation with respect to x. That's something easy to do. I expect everybody know how to do in the MST end of term test. Now you get differentiate with respect to y now. Okay, this means differentiation with respect to y. So basically it means differentiate f with respect to y. It means differentiate with respect to y now. Now ln x squared minus y. Again, differentiate ln something, you get 1 over something. The same thing. So 1 over x squared minus y. But then you cannot stop here. Must differentiate with respect to y, x squared minus y. When you differentiate with respect to y, you keep x squared constant. So you get 1 over x squared minus y. This is 0 now. Okay, differentiate x squared is 0 because x is constant now. Minus 1. Differentiate y minus 1 now. So equal to minus 1 over x squared minus y. Okay, this is how to do question 1a.
Sure.
Yes?
Then go through how to do question 1C and 4B.
1c and 4b. Let me see.
Yeah.
1c and 4b. Okay, fine. Let me look at 1c first, then I get 1c first. This thing you ask. So 1c and 4b. Let's look at 1c first. Question 1. Okay, 1c and 4b. Okay, so this is partial differentiation question. Okay, new. Okay, 1c and 4b. So I think I need more space. Okay, this one you need quite a lot of working to get answer. I will not show you the detail, just show you the idea how to do this. You have a timber, okay? The height of timber is increased by 0.5 meter per year. So basically, you will get your information. DHCT is positive 0.5 meter per year. Every year, the height of timber increased by 0.5 meter per year. And circumference increased by 0.2 meter per year, right? Let's see the calculation. Okay, circumference is 0.2 meter per year. The volume of timber is increasing, okay? At what rate the volume of timber is increasing? At what rate volume of timber is increasing? This is actually looking for dVdt. Okay, they are looking for dVdt, right? dVdt is what? They are asking for this. Okay, dV volume, right? The H when H is equal to 6, the circumference is equal to 1.5. So do you know the formula for the circular cylinder? Okay, so because the triton is a circular cylinder, so volume is actually, okay, if based on the circular cylinder, it's pi r squared. Normally people are not look at this, r and h, right? The volume of this is pi r squared times h. Okay, unfortunately they don't use this formula. So either you convert this, okay, either you convert this. So what is actually circumference? Circumference is 2 pi r. Okay, circumference is 2 pi r. So c equal to 2 pi r. So what is r now? R is equal to c over 2 pi. So, okay, so you have convert this one. V is equal to pi c over 2 pi square times h. So you can cancel this one, pi c square over 4 pi square times h. So after cancellation, V is actually 1/4 pi c square h. So the volume become like this. So how to find the rate of change? Okay, use this one. dV dt is equal to, okay, dV dc, then dc dt plus dV dh, then dh dt. So this chain rule again. Okay, so you need to calculate dV dc, right? So let's look at here. So we have a formula for the volume now, then you just differentiate now. Okay, dV dc is equal to what? Okay, so I copy 1 over 4 pi c h, right? So I make the next page here. V is equal to 1/4 pi c square h. So partial differentiation with respect to c is 1/4 4 pi 2c, integrate c squared get 2c, right? H here. So actually 1/2 pi ch. And then dV dh now, this is easy. So copy formula, differentiate by to h, you get c squared. Okay. So then plug in formula again. So dV dt, okay, is actually dvdc dcdt plus dvdh dct here. So this dvdt is 0.5. Okay, why is it 0.5? Because the question is also right. 0.5 dvdt. I don't know actually. Sorry, I mixed up question already. I don't know this. Okay, this one is actually 1/2 pi chc is I dcdt, right? So what is c and h here? Let me write first. dcdt, after copy the formula, copy the information. Okay, the dvdh is 1/4 pi c square dcdt. Now copy this information. What is dcdt? Is 0.2. So 0.2 here. This 0.2. Your c is how much there? On the question, c is equal to what? Circumference is 1.5. H is 6, yeah? 1.5 and 6. Circumference is 1.5. C is 6 here. So we get this. Okay. 1.5 times 6. Okay. Times 0.2. Okay, so it's 1.5 times 6 times 0.2. Okay, because C equals 1.5, H equals 6 there, and then this 1/4 pi, C equals 1.5 now, square. The height, in this case, dHdt is actually what now? 0.5. So you press calculator and see what it is thing. Okay, so let me check calculator here. So it's 1.5. Okay, 1.5 times 6 times 0.2. Okay, and so this is actually divided by 2 pi. Divided by 2 pi. Okay, first term is 0.2865. Second term, let's see what is it now. Okay, 1.5 square. Okay, times 0.5 divided by 4 pi. In 0.08. So add together. So 0.3766. 0.3766 meter cube per year.
Teacher,
Yes.
for the you know the circumference
Circumference, yes.
EDT, the number right I divided by 2 pi
Divide by 2 pi.
to find the DRDT.
Let me see what do I make mistake there.
No, I mean that's what I did.
Oh, circumference. Oh, you want to R is circumference is C. The R is equal to C over 2 pi, right?
Yeah.
Yeah.
Can I do that to find the DRDT?
Of course, then you must change the formula lah. That means you actually don't use this formula. Okay, that means that you don't use this formula. Go ahead, don't do this one. Straight away, start from here. Then you find the RDT. Okay, from here. Don't need to find the CDT.
Okay, thanks.
Okay. So this is a suggestion. I mean that many ways to do this question. In fact, in our class, I just don't forget the solve formula. Just use R straight away. So you have to find out R in this case. R is equal to C over 2 pi. Okay, then you can find out y is dc dt in this case. Fine. Okay, so this is a question for C. Okay, then I look at search by C, right? Then I look at that question. You can request. Ask question only, right? Okay, the next question is, I think it's for B, right?
Yeah.
Okay, for B, I think what is for B here? For B. This is a tough question. Okay, 4B is a tough question. Okay, so most people cannot do this question. Okay, so where is not this picture? Go and lost page here. Yeah, this is a page here. So I'll go to 4B now. Insert the page here. 4B. They give you the hint already. Okay, the only thing is you try not to mess up because they are integration, trigo, everything mess up together, so it makes things very messy. Okay, they give you substitution away. So let's try substitution. You say x must replace. So x is equal to 1 over square root 2 sine theta. So what is dx d theta now? So it's 1 over square root 2. Differentiate sine equal cosine theta. So your dx is actually 1 over square root 2 cosine theta d theta. Okay, this is your dx here, which you will need this. Dx is here. Okay, next thing, I want to figure out what is 1 minus 2x squared square root. So, because if you try to do everything in one go, you make things very messy. Okay, 1 minus 2x squared. So this is the trick here. You just concentrate on your trigo part. Afterward, then yeah. So this actually square root of 1 minus 2. Now x is equal to 1 over square root 2 sine theta. Okay, square. So when you square it, become 1 minus 2. 1 over square root is 1 over 2 now. Sine square theta. Right, square it. And then you'll find that there are log cancellation. And so this becomes square root of 1 minus sine squared. Of course, you know trigo formula, 1 minus sine squared is the same as cosine squared. So you need quite a lot of trigo to back you up to do this. 1 cosine squared. Take a square root, of course, it's cosine theta. So I figure out this thing is cosine theta. This thing here is a cosine theta. Right? So put them together, just ignore limit first. So you're actually doing integration. Okay, actually is cosine theta first. Okay, cosine theta is the green portion, and then the yellow portion is what? 1 over square root 2. 1 over square root 2 cosine theta. D theta. Okay, so you can pull out 1 over square root 2 now. 1 over square root 2. This is cosine square d theta. Okay, become like this. 1 over square root 2 cosine square d theta. Now you recall the trigo formula. How to integrate cosine square? Okay, this trigo formula when you do the beginning chapter 2, right? A lot of trigonometry is reducing the square. So this actually equal to, I mean, use an page now. This actually you want to do this. So another page here. 1 over square root 2 integrate cosine square d theta. This is using reducing square, meaning that cosine square theta is equal to 1 plus cosine 2 theta over 2. Okay, this is on page 27, reducing square. So this is 1 over square root 2 now. So this is actually 1 plus cosine 2 theta divided by 2. Okay, take out 2 again. So 1 over 2 square root 2. Integrate 1 plus cosine 2 theta. Then integrate term by term. 1 over 2 square root 2 theta. Integrate cosine theta, you get sine 2 theta. Divided by 2. And a lot of time people forgot to divide 2. Okay, let's see. Okay, this is the first part. You integrate this one. Then I want to change the limit now. Okay? The limit for the question, let's look at the limit here. Okay? 0 to 1 over square root 2. Okay? So limit here, I will work on here. So your x equal to 1 over square root 2 sine theta, right? So I'm going to put a limit now. So your x equal to 1 over square root 2 sine theta. What is the lower limit in this case? Lower limit is 0. So when x equal to 0, when x equal to 0, what is the theta now? Okay, your 0 equal to 1 over square root 2 sine theta. So that means square root 2 times 0 equals sine theta. So 0 times 0 equals 0, right? Sine theta equals 0. So what is theta now? Theta equals 0. Straight away. Okay, what happens when x equal to 1 over square root 2? Okay, I must bring up a bit a space here. Okay, bring up this one slightly up here. Okay, when x equal to 1 over square root 2, right? What is theta now? So you put there 1 over square root 2. Okay, x equal to 2 now. 1 over square root 2 sine theta. So that means 1 equal to sine theta. So what is theta now? Theta equal to sine inverse of 1 into pi over 2. So you have actually these two answers here. Theta equals 0. Okay, theta equals 0. And then the other one, theta is equal to pi over 2. Okay, so what you actually want is actually 0 to pi over 2. 0 to pi over 2 here. So they only pass C now. So theta from 0 to pi over 2. So put in the answer. 22 pi over 2 plus sine of 2 times pi over 2 minus 22 equals 0, sine of 0, okay, over 2. So you find that all these numbers are 0. Sine pi is 0 here. Sine 0 is 0. Sine 0 is also 0. Everything is 0 except the first term. So it ends up is 1/4 square root 2 times pi. Okay, that's the answer for this question. Okay, I think by that I will stop. Answer already. Okay, so okay, I think that's all right. Let's final check. This Lina is still there. Okay, Lina is not here, right? Lina, are you here? So I mean, okay, so just Lina is not here today. That means all fine. Okay, that's today. So we will see you. Okay, so okay, I'll see you on the 3rd of June, right? 9:30 to 10:30, right? Remember to do the learning end, okay? 31st of May is the last day. Okay, that I stop working now, okay? It's fine. So see you next Wednesday, right? Next Wednesday, 9:30 to 10:30 p.m. a.m. Sorry. So that will be all. Just stop recording now.